Hi everyone, today we present our work, How Talk to Language Models, Serialization Strategy for Structured Entity Matching. Entity matching, which identifies whether two data records refer to the same real-world entity, is crucial for knowledge-based construction and enhancing data-driven AI systems. Classic entity matching tasks focus on structured data in relational tables with homogeneous schemas, where a more recent study has expanded the problem scope to match semi-structured, unstructured, and complex relational data, as well as entity with missing or noisy input attributes. Pre-trained encoder models such as BERT has been widely applied to resolve and matching entities based on their textual attributes. For entity matching tasks, the model takes a pair of entities serialized by the function as input and is fine-tuned with objective in two common settings. As cross-encoder, the join of serialized entities is fed into model simultaneously, followed by a classifier predicting match or no match. As bi-encoder, serialized entities are fed into model independently, and their similarity is computed by a score function over their embeddings. Recent work have gradually adopted large language models for solving entity matching tasks through chat-based interactions, such as querying model to match a pair of entities through prompts. Ask the model to compare the entity tuple or select the closest one from the entity list. But they generally suffer from the throughput bottleneck in the decoding phase. Hybrid methods such as ChatEA use pre-trained models embedding for first-stage filtering, and then call GPT models for refined entity comparison. This two-stage strategy reduces a certain complexity, but still faces challenges in long latency and high inference costs due to API costs. This reveals one of the pressing problems in how to utilize language models efficiently and effectively for entity matching. To address this problem, we first investigate how different serializations of structured entities affect the utility and efficiency of language models for matching tasks. The serialization schemes determine how structured entities are converted into sequences, which affect the model's ability to interpret the input. Specifically, we benchmark the effects of serialization schemes listed in the table for pre-trained encoders and open-source large language models under zero-shot and fine-tuned settings. We quantify and analyze the impact of attribute order, sequence formats, and special tokens in entity serialization on the model performance. We aim to answer three key questions here: whether attribute order matters, how different ways of handling missing or dirty values from the input affect the model, are special tokens in serialization helpful for matching structured entities? Our empirical study seeks to understand the optimal form of serialization to maximize the matching performance of different language models on tabular and semi-structured data. We briefly summarize our findings here. With fine-tuning, pre-trained encoder models are more sensitive to how entities are serialized than large language models are structured entity matching tasks. Both encoder models and large language models have a preference for serialization schemes that are close to the crops they were pre-trained on, especially plain text without special tokens. Injecting randomness into attribute order during serialization can be beneficial for models and supervised fine-tuning, especially on noise data. Building on our findings, we explored new strategies for large language models to efficiently encode structured entities with complex relations, especially with application to entity alignment in knowledge graphs. Unlike tabular or semi-structured data, knowledge graph entities not only contain attributes, but they are also connected to each other through complex relations. This poses great challenges in how to effectively encode KG entities and efficiently use LLMs to extract their semantics and structure information for matching. Existing methods leverage graph encode functions, abstract code format, or use sequence-to-sequence models to verbalize KG entities. This method primarily focuses on flattening graphs, but not able to maintain the semantic relationship and structural context between structured entities. To tackle this challenge, we propose a lightweight serialization approach for graph structured entities by sampling semantic meaningful passes on KGs through random walks. Its walk-based serialization naturally encodes the local structure of the KG entities in a sequential form, in which relative positions and semantic relationships between entities are embedded. Lastly, to address the scalability challenge of using large language models for matching, we adopted LLM'25 that converts decode-only models to entity encoders. This approach is paired with walk-based serialization and contrastive learning objectives for model fine-tuning to generate high contextualized entity embeddings for matching with high throughput and low latency. In summary, we systematically studied the effects of entity serialization on language models with different model sizes and backbones for matching structured entities. We empirically find BERT-based encoder models are more sensitive to serialization than LLMs, especially in terms of attribute order and data quality. Both types of language models prefer serialization schemes that are close to the text crops on which they were pre-trained on. When entity attributes are noisy, injecting randomness into the input can benefit the model's performance. By applying these findings, we propose a random walk-based serialization for open-source LLMs to scalably generate robust embeddings for matching KG entities. The proposed LLM walk achieved state-of-the-art performance and is 3 orders of magnitude faster than GPT-based method. For more details and experimental results, please refer to our paper. Our code is also publicly available on GitHub. Thank you.